Right, next one we have the Dask demo by no other by that Bernhard from Pachama. So welcome, Bernhard, and thank you for joining.
Hi, thank you very much for having me. I will make this fairly brief, I hope, as other plugins in this realm already exist, the Spark plugin, the Ray plugin, and I just want to give a quick overview of basically what the new capabilities are. So, yeah, basically, this is a short presentation of what the Dask plugin in Flyte is about. As for the agenda, a quick why on, because a lot of plugins already exist. Why add another one that is fairly similar? A short intro on what Dask's compute model looks like, because I think that's going to be helpful for the demo. A quick note on how to set up things, a demo, and then questions. In case there are questions throughout the talk, feel free to just interrupt me. As said, this is fairly informal. On the why, you might think, okay, Dask orchestrates tasks across machines, right? Very similar to Flyte or Spark. So why another plugin? And I think the main reason is that Dask's compute model allows you to run way smaller tasks as the nodes are constantly up. So with a Dask cluster, you have nodes that are constantly up versus with Flyte, you get each task is a Kubernetes pod, so the overhead of starting a task is a bit larger in Flyte. So similar to, for example, Spark, tasks are just way smaller and allow for different scheduling. Then why not Spark? I think Dask is nice in regards that it's written in pure Python. So I think that a lot of data scientists and machine learners like that. It also tries to abstract tries to aim for a similar API as X-array and as NumPy arrays and pandas data frames. So I think the APIs are very similar to the data science community, which is quite nice. And there's really great integrations for certain domains. For example, I work in the geospatial domain at Pachama, and there's just a big ecosystem of tools that build up on Dask. So it's nice for us to have a very simple way to spin up a Dask cluster, run those tools, and then shut the cluster off again. With one of the big benefits being that even with multiple teams, right, you could have Dask clusters up all the time. But then with big teams, they want different dependencies, right? One team wants TensorFlow, the other one wants geo dependencies, whatever. And to not get into dependency hell quickly, it's nice that Flyte can just spin up a Dask cluster on demand, run the job, tear it down again, and you have full control over all the dependencies and whatnot, which is quite nice. For the overall compute model, it works, as I said, fairly similar to what you would get in a Spark job. You have a cluster with a scheduler, which is the main entry point that schedules the work. Then you have an arbitrary amount of workers. I think pretty much as many as your Kubernetes cluster can handle. And maybe one special thing is that in the case of this plugin, we have a job runner. It's basically, you can think of it as a pod that submits work to the scheduler. In a regular use case, right, it's the typical client. You could have multiple clients working with one scheduler. In the case of this plugin, we have one client with one scheduler and a bunch of workers. And I think that's somewhat important to understand how the plugin works. So demo time. Basically, what you will need to do to enable the plugin is first install the Dask operator. I have included a link at the end of the presentation. It is an operator that can manage Dask clusters. If you set it up with Helm, it's usually in the minutes of work, kind of order of minutes. Then in your Flyte config, in the config map, you need to enable the Dask integration, and you need to enable you need to map the Dask task type to the Dask plugin. So you definitely need those two lines. You probably already have some in there, and you want to keep the ones that you have, but these are the additional ones that you will need. Then on the Flyte level, the way this looks is you have your regular Flyte task. As always, the difference is in the decorator, where you have a config which configures the three parts that we just talked about. So the job runner, the scheduler, as well as the workers. And you don't necessarily need to set things here. I just set some for demo reasons, but you can set different limits, requests, etc. for those parts. Explicitly for the scheduler and the workers, you can specify how many workers you want. And all the things that are outside of this task config will apply to the job runner. So think of the job runner as your regular pod task that you usually have in Flyte. It's just the client, and all the config that you apply outside of the task config will just apply to the job runner. The plugin supports all the things that you would usually expect: interruptible tasks, passing on environment variables, secrets, and all of that. And it also supports running locally, which is quite nice for testing, right? For local iteration. And then as soon as you register, you can just unleash the full power of your Kubernetes cluster. And we've scaled up quite large with this, and has been working well. I've included a small demo here. The way that Dask works is when you don't have an explicit client, it will get the implicit one. So when you run this locally, it will get a local client implicitly. You could also create one if you need a special local cluster or whatever. And in the cloud, or when you run this in Flyte, you will get the client that is connected to the scheduler that this task decorator creates. So there's very few lines. As said, most of them are not required. Actually, I think you don't need any of the ones. You only need this task line here. I can run this whole thing locally, and it hopefully works as expected. Let's see. The demo goals are good. Yeah. So you can run this locally. You can integrate this into your PyTests. You can do all the nice regular stuff. And then when you register this, when you register this, right, you need to register it with a Docker image. The Docker image needs to have Dask and Flyte kit as well as the plugin installed. So that's what this is doing here. And then when you go to the UI, you should have this workflow here, this task workflow. You can launch it. In this case, it doesn't take any input parameters. It could. And when you launch it, in the background, when we look at lens here, it will create a job runner. It will create a scheduler. In this case, we only specify one worker, so it will create a worker pod. It will do the work as you would usually expect it. And see, then the work succeeds. This also succeeds, hopefully. It usually takes a while. And the output is the same. So that's the full round trip. As said, setting this up shouldn't be too much work. I think that was mostly it. I added a few links here. I don't know if there's a good place to share this documentation. There will be a blog post on the Dask site that has all the links and a bit more in-depth description of how this works in the backend. This is mostly an overview. Yeah. Are there any questions?
This is awesome, Bernhard. One question I had is, I guess I heard that you went into the Go land and helped implement the backend part of this. How was that experience, and what are things we can do to move that along?
I think as part of so that what you've seen currently is basically running on my local setup. So I do have a local Kubernetes cluster with an installation and everything, and I want to say just setting things up to being able to develop was a bit of a challenge, and I've deployed Flyte a couple of times in production. So at least I knew which parts to touch. That being said, I've also never asked on how all of you guys do this, so I figured I can just put the things together the way I wanted to. Maybe for reference, I did have a local propeller running that I could debug into. And then just started. The Spark plugin is very similar, so I tried to mimic that. And I want to say, don't be afraid of Go. At least the parts that I've touched were quite easy to learn. It was also enjoyable to see something different. But yeah, I think the development setup was probably the trickiest bit, especially given when you change something in Flyte plugins, you want to make sure that that's in your propeller, right? But then your propeller compiles locally and it uses the Flyte cluster. I think that wasn't. That I can imagine that being tricky, especially if you're not so familiar with Kubernetes and Go and all those bits.
Okay, awesome. Yeah, I think we'll we'll make that contribution experience better, but then also with the external web API plugins, people in Python can sort of implement their backend behavior more easily, I suppose.
Okay. If anyone needs something, I'm happy to help out there. So if anyone in the community needs to implement a plugin, I'm happy to help set up things. And also, thank you for the help that I've gotten throughout. This has been a 6-month project, not because it was too tricky, but mostly because I did this on my weekends, and they are a bit of a scarce resource. So thank you very much. And we are using this in production at the moment. We just switched. So there might be 1 or 2 bug fixes coming, but so far it's running our workloads and it's good.
That's great. Thank you so much, Bernhard. I mean, this is awesome. Any other question or comment regarding the Dask integration?